All right, so we're going to do another day on what we did yesterday with the sliding and dividing. Before we do that, let's do a few warm-up problems. Take a look at the first one on the far left. Okay, they all happen to be multiple choice today, but take a look at that first one on the far left. Do you guys see that word product? What does product mean to do? Multiplication. So I am going to multiply these things. Now, you all know that multiplication can be shown by parentheses, right? All right, so take a look. This should be very familiar to you. Do you see these coefficients? What do I do with them? You multiply them. So grab your calculator, type those fractions in, and multiply them. Okay, so unfortunately, these all start with 2/5, right? So I can't eliminate any answers. What do I do with these A's? Okay, what do you get? So that looks like I can eliminate B and D. So the answer is going to be A. Wonderful. Any questions here? No? Okay, let's go to the bottom one over here on the right, please. Bottom one on the right. Can somebody read this to me? How do you read this statement right here? Okay, how many numbers are there that are greater than or equal to -2? A lot, right? A whole bunch. And I can't possibly write them all, correct? So how do we write our answers? What are these bolded things? What is this right here? What do we call those? Starts with I know, at Pictionary. It starts with an S. SH. SHA. SHA. This is shading. Do you remember how we shaded the way the arrow points? Do you guys remember talking about that? So we shade inequalities because we can't possibly write all the answers. It's impossible. You'd literally sit down to do one problem and you'd be writing for the rest of eternity. Okay? So we shaded these things. Can you decide which of these is shaded appropriately? A, C? Could it be B or D? Tell me why it can't be B or D. Because these open circles, they're supposed to be closed because of that equals bar right there. So it can't be those two. So is it A or is it C? Because greater than means that way, doesn't it? So my answer here would be C. Good. Okay, last but not least, it says, what is the solution set of x squared plus 2x minus 24 equals 0? Now, folks, I basically have to solve this. That's what it means to find a solution, yes? Now, normally when we solve, you guys like to isolate the variable. So you would be adding the 24 over, correct? But take a look. Don't I have x squared and x? That is two types of variables. How do I know which one to isolate? You don't. These are the types of problems we solved before break. You have to set it equal to 0, which it is, and then you have to factor it. Well, what's our first step in factoring? Do we have a GCF in these three terms? We do not. Does it start with a 1? Yes, so I do not need to slide and divide, folks. All I need to do is write my two binomials. What are they going to start with? And I'm looking for factors of 24 that will subtract to 2. 6 and 4. And what do I know about my symbols? And the bigger one has to be adding. So that's what my factors look like. Now, remember, I don't have to divide by anything here because this started with a 1, didn't it? So we're almost done. If it's equal to 0, one of them has to be 0. What will make this first one be 0? What will make the second one be 0? So what answer would I then choose? J, the fourth one. Nope, you're right. This guy down here. How's everybody doing? Now, what would happen if I took this 4 and plugged it in up there? Let's try it. Grab your calculators. If I take this 4 and I plug it in for the x, wouldn't that be 4 squared plus 2 times 4 and then minus 24? What do you got? Is it that what it's supposed to equal? Yeah, so what do you think would happen if I put the -6 in there? It would what? I just didn't hear what you said was all. What happens? So folks, remember when I put a negative in there, I have to put it in parentheses, right? No. Did you type it in like this? You didn't type it in like this. Which shouldn't it be 0 if it's going to be an answer, folks? Doesn't it have to make it equal what it's supposed to? Yeah. Okay, so let me ask you this question then. What if I would plug in this 3? You would not get 0 because it's not an answer, is it? Does that make sense to everybody? Okay, wonderful. Are we ready to go ahead and do a few practice here? And then we'll be on our way. There is no new material today. It is all sliding and dividing. Okay, so before we even get to sliding and dividing, what do we always have to check for first? Okay, that's always first and foremost. You can't forget about it. Okay, GCFs are good because GCFs make our numbers smaller. Okay, and smaller numbers are definitely easier to work with. Then it's been a while, but how do we do 4 terms? We group them. And when you do group them, it's 2 by 2. And I think I probably need to bring out one of those problems back and make sure remember how to do that. Maybe tomorrow we'll do that. Okay. Then if there's 3 terms. Okay, now it is a binomial and a binomial. But we only go straight to this way if it starts with a what? A 1. We only go straight here if it starts with a 1. Okay. If it doesn't start with a 1, what do we have to do? We have to slide and divide. And we use this if it does not start with 1. Everybody doing okay? Yeah? All right, so as you can see, we are going to write those 4 steps that we use for slide and divide, and we're going to keep those all the way to the left. Do you see the problem that is over to the right of your page? Yes? So just like yesterday, please keep all your writing to the left, and we'll solve the problem on the right. First of all, what's wrong with that problem? It's backwards. It's in the wrong order. So how are you going to write it? Is everybody all right with that? Yep, that's a Z. I know, it kind of is very thin in the middle, isn't it? Okay, now remember, our first step is to look for a GCF. Do I have a GCF? Yes. What can I divide all of them by? 2. So we're going to go ahead and we're going to take a 2 out. You can divide them all by 2. Yeah. Yep. Think about it, 50 cents is 2 quarters, right? Okay, so if I take that 2 out, can you tell me what would be left? 2z squared minus 15z. Okay, now folks, remember, I am no longer concerned with this GCF of 2 out front. In fact, I'm going to put it all the way down here to the bottom so I don't forget that it goes in my final answer. Is everybody all right with that? Okay, does this thing start with a 1? It does not. It starts with a 2, doesn't it? That 2 right there I'm concerned with. What do I do with that 2? Okay, we're going to slide it. And is everybody okay if I use LC for leading coefficient? Okay, slide the LC to the end and multiply. So here we're going to be sliding the 2 all the way to the back with the 25. And what will that then make? 50. Yep, you're right. And now it's back up to 50. Now, guys, can I show you something here real quick? Stop after this step and just kind of let me show you what would happen. What if you didn't take out a GCF? You would then be taking this 4 back to this 50, correct? What's 4 times 50? I don't want to have to deal with 200. Do you see how my number got much smaller when I took out that GCF? Okay, just want to make sure that we're all aware what the GCF will do for us. Okay, so now that I have that, this thing starts with a 1, doesn't it? How do I factor things that start with a 1? Correct. We're going to factor by a binomial times a binomial. What will my binomial start with? Z. And we're looking for factors of 50 that will add to 15. 5 and 10 will work. Do my symbols need to be the same or different? And they both need to be, okay, how's everybody doing? Okay, but remember, that didn't actually start with a 1. What did it start with? A 2. So now we need to divide by the original. And again, I'm going to use LC for leading coefficient. What was that leading coefficient that we slid to the back? It was a 2. Notice I circled it. The whole point of me circling it is so I can find it easily. So we're going to divide those by 2. Does 5 divide by 2? It does not. Does it reduce? 5 over 2 just stays 5 over 2. How about 10 divided by 2? Okay, now, the fourth and final step is to get rid of any denominators. What's a denominator again, guys? Okay, so that's the bottom. Get rid of any denominators by sliding to the front. Okay, so this 2 right here is going to be slid to the front. And that'll be 2z minus 5. And then we have z minus 5. And again, notice I have my GCF of 2 that remains in the front. All right, so how we doing? Fair enough? Make you the same deal I made with fourth period? We'll do 6 problems and we'll call it a day. That's what they tried to negotiate with me too. No, I'm not negotiating. No, we're going to do 6 problems. 6, and we'll call it a day. Okay? I'm going to pick 3 of them, and you get to pick the other 3. So does anybody have one they would like to see? First row, number 9. That's okay. We can go all the way to number 9. Good choice at number 9. What are we looking for first in number 9? Is there a GCF? What is it? It is 2. 18 does not divide by 4. Yep. So it's just a 2. It's okay. What's left if you take out a 2? Okay. That's okay. We're doing okay. Does everybody see the 2 that's out front? I'm done with it. I'm going to take that 2 and move it all the way to the bottom where I'm going to put my answer. Everybody okay? What's the new leading coefficient? It's a 9. We need to slide it to the back, please. When you do that, what do you get? It is 36. Does anybody have any questions there? Are we sure? We're good? Now it starts with a 1. So what are you going to make? Yep, and they're going to start with y's. You're looking for factors of 36 that will add to 12. Factors of 36 that will add to 12. So if you don't know, there you go, 6 and 6. If you don't know, you're grabbing your calculator and doing 36 divided by and trying some numbers. What do I know? Excuse me. They're both the what? Same, and they are. Okay. Now, what leading coefficient did we slide to the back? The 9. So I have to divide by that 9. Does 6 divide by 9? It does not, but it will reduce. It should be 2 over 3. Those are both divisible by 3. Okay. 6 and 9 are both divisible by 3. And they just so happen to be the same. Okay. Now, how do I get rid of this denominator? We're sliding it to the front, so it'll now be 3y plus 2 and 3y plus 2. Just something to be aware of, folks. And this is not something that you need to write. But do you see how these 2 parentheses are the same? So if you wanted to, you could say that it's squared because there's 2 of them. Isn't that what it means to square it? Write it twice? Okay, so this means the same as that, but I just want you to be aware of that. Yeah, that's Spanish class over there. They've been doing that all day. Yes. Everybody doing all right here? Okay, that's one of your guys's. Find me number 7. So, hey, this is what I was going to do. So good. Now, what's up with number 7? It starts with a negative. So that's going to be part of my GCF. Is there anything else that can be taken out as a GCF? A 2? Anything else? I can actually take out a negative 2x squared. All of these things have an x squared in it. So we're going to divide the whole thing by negative 2x squared. When I do that, remember folks, the numbers out front are getting divided. So what is negative 2 divided by negative 2? Nothing. It's 1, right? So I don't really need it anymore, do I? What am I doing with these exponents? And so that'll end up being x squared. Does everybody understand where that x squared comes from? Yes? Okay, so what is negative 12 divided by negative 2? Positive 6. And if I subtract those x's, I just get 1. And then how about negative 18 divided by negative 2? And then those x's will cancel out. Okay, now we got some good news here, folks. This trinomial starts with a what? So do I need to be sliding and dividing? I don't. I can go straight to making 2 binomials. Now, when you do that, please don't forget to drop down your GCF into the answer. What are you going to start your binomials with? And I'm looking for factors of 9 that will add to 6. Okay? Symbols will need to be the same, and they both need to be. Now, just like that last problem I showed you, because those two parentheses are the same thing, you could also write it like that. Now, am I telling you need to write it like this? No, I'm just telling you could if you ever see it that way. How we doing? Okay, can you find me another problem on this page that would not need to be done by sliding and dividing? 10 does not need to be done by sliding and dividing. Because it starts with a what? A 1. So what are you going to make right off the bat? Okay, what are they going to start with? Use. You're looking for factors of 12 that subtract to 1. 4 and 3. What do we know about my symbols? They're different, and the bigger one has to be addition. And that's it. Okay, I'll let you guys choose one more. 4. Oh, not too bad. Question, do you have a GCF? They don't all have an R. Nope. So does it start with a 1? It doesn't start with a 1. No, you're not. You're just thinking before you're speaking. So what do you get when you slide that to the back? Yep, minus 60. And folks, remember that's an s squared. Okay. Now that we made it start with a 1, make those 2 binomials. What are they going to start with? What are they going to end with? Notice they do need to end with s. We are looking for factors of 60 that will subtract to 11. Factors of 60 that will subtract to 11. So grab that calculator, put a 60 in there, and we get 15 times 4 will work. What do we know about our symbols? And the bigger one has to be subtraction. Okay, now it didn't actually start with a 1. What did it actually start with? A 20. Now, 15 does not divide by 20, but it will reduce. What can both of these numbers be divided by? Hold on, what can they be divided by? 5. And when you do that, you get 3 over 4. Okay, what can 4 and 20 be divided by? 4, and you get 1 over 5. Okay. Slide the denominators to the front, and we get 4r minus 3s and 5r plus s, or plus 1s if you so choose. How many problems am I up to? How many was that? That was 4, so I need 2 more. Yeah, I'm going to do another one with a GCF. Let's see. How about number... Maybe I don't have another one with a GCF. I don't. Can you give me 2 more problems, then you can? Okay, so I don't have any more with GCF, so can you guys just pick for me? 3. Right there. Is there a GCF? No. Does it start with a 1? No. If we slide it, what do we get? Nope. There we go. 24. You okay, Dylan? Everybody's good? All right, make your 2 binomials. Start them with t's. What are we looking for? Factors of 24 that add to 14. Factors of 24 that add to 14. 12 and 2. Symbols have to be, and they both need to be. Okay. What was the original leading coefficient? 3. Does 12 divide by 3? It is. Okay. Does 2 divide by 3? Does it reduce? No. So I'm just going to move that 3 forward right off the bat, since it doesn't reduce. All right. What's my last one going to be here? 2? Okay. GCF? No. Start with a 1? So slide it. So x squared plus 10xy, you said 24. Okay. What are we going to start our binomials with? What are we going to end them with? Okay. You're looking for factors of that will subtract to 10. 12 and 2 again. I know. Symbols will be different, and the bigger one will be positive. Notice the positive in the middle there. All right. What was the original leading coefficient? 3. What is 12 divided by 3? Does 2 divide by 3? Does it reduce? No, so we're going to move that 3 to the front and get 3x minus 2y. All right, so how many for extra credit do you have? Awesome. And those of you that needed to fix a couple things on your homework, hopefully this 15 minutes will get that done so you can turn it in. Okay, your homework is... Logan, once you get that written down, you can take a lanyard and go to the restroom.
Yes, buddy. Never mind.